This video covers quantum numbers and how to assign quantum numbers to electrons. One important thing to realize is that this video has been designed with the idea that you already covered electron configurations and know how to write electron configurations. I'd like to point out that these are the quantum numbers. There are four, N, L, M sub L, and M sub S. The deal is that in an atom, every single electron is assigned a unique set of quantum numbers. In fact, the Pauli principle, Wolfgang Pauli came up with this, says that no two electrons in an atom can have the same quantum numbers. It's like one of the laws of physics. So every single electron has a unique set of quantum numbers. Now, that means if you're, for instance, nickel, and you have 28 electrons, each of those electrons has a separate set of quantum numbers. Usually the only one that we really care about is the last electron added, because the four quantum numbers for the first electron in an atom will always be the same. It'll be energy level 1, L will equal 0, M sub L will equal 0, and M sub S is usually written as positive 1/2. That'll be the same set of quantum numbers for the first electron in any atom. Doesn't matter if it's hydrogen, helium, lithium, beryllium, blah, 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 blah. Every single atom will have the same one. So if you really want to talk about different elements, you're really talking about what's the last electron added, because that's the unique one. That's the one that makes that element unique. Every single element after that will have the same electron with the same quantum numbers. But if you want to, for instance, say what's unique about lithium, you're going to say, oh, it's the last electron added to lithium is in the second energy level, and it has these quantum numbers. All right, these are the rules for assigning quantum numbers. N will always be whole numbers starting with 1. These correspond to the energy levels. So there's a first energy level, a second energy level, a third energy level. L is called the angular quantum number, or the angular momentum quantum number. It will always go between 0 and n minus 1, which means that it can get as high as one number under n. So in the first energy level, you can only have L equal to 0, because n minus 1 is 0 for the first energy level. So you'll only have one possible value of L for the first energy level. For the second energy level, when n equals 2, you could have L equal to 0, or you could have L equal to 1. So you have two possibilities for the L quantum number in the second energy level, and it's so on, so on, so on. M sub L can range any integer between negative L and positive L. So that's why in the first energy level, you can have an M sub L only of 0. But in the second energy level, you can have an M sub L is negative 1, or 0, or positive 1. Notice that's actually three different possibilities. Those are pretty much the orbitals and the p orbitals. So there's three different p orbitals. That's the different quantum numbers for the p orbitals. And finally, M sub S is the spin. So you can have a spin down electron or a spin up electron. So one last time, these four numbers, the four quantum numbers, are unique for every electron in an atom, and they describe that electron, what orbital it's in, what energy level it's in, whether it's a spin up or spin down electron, and every single electron in an atom must be unique. All right, these are all the possibilities. You've seen this table before. Since you know electron configurations, I'd just like to point out to you, for instance, if your electron configuration ends with 3p4, well, we can actually figure out which electron that is on this chart. It's in the third energy level. P means it has an angular momentum quantum number of 1, so it's in this row. 3p, hey look, right there. And then there are three different p orbitals. Well, you know from the orbital filling diagrams that they're going to fill like this. And so the fourth electron is going to be a spin down electron in the first orbital. So it's going to have a negative 1 M sub L value, and its M sub S is going to equal negative 1/2, because it's a spin down. The negative spins are the down spins. Hey look, now we know all four quantum numbers for that electron configuration. It's going to be 3, 1, negative 1, and negative 1/2. So just to point out again, these are the four orbitals. The S has an L of 0. The P has an L of 1. The D has an L of 2. And the F, which I haven't drawn, has an L of 3. All right, the S only has one orbital. That's because it only has one possible M sub L value, 0. The P's, there are 3 different P's. That's because there's 3 different M sub L values. It's -1 or 0 or +1. The D's, well, remember that the M sub L could be positive or negative L or any number between them. So the M sub L's are -2, -1, 0, +1, and +2. All right, so you can see that right there is all the L and M sub L quantum numbers. The N quantum number, remember, is just the energy level it's in. There's an S in the first energy level. There's an S in the second. There's an N in the third. There's an S in every energy level. The P's are only in the second energy level and third and fourth and fifth. There are no P's in the first energy level. The D's are only in the third energy level and higher. There are no D's in the second energy level or first energy level. And the F's only appear in energy level 4 and higher. So notice these rules that we had for the quantum numbers, that L has to be an integer between 0 and n-1. That actually controls the fact why there aren't any D's in the first energy level. Because if the D's were in the first energy level, it would have an L equal to 2, but you can't have an L equal to 2 in the first energy level because L can only be between 0 and n-1, which is 0. So in the first energy level, you only can have an L equals to 0. That's why the first energy level only contains an S orbital. All right. So we can see some more examples from electron configuration. Hydrogen, 1s1. So n is equal to 1 because of the 1 in front. S means L equal to 0. The 1, M sub L, has to equal 0. Now, it doesn't always equal 0 for every time there's a 1 here. Pretty much you can only figure that one out if you draw the orbital diagram. So you have to know that there's only one orbital in the 1s, and since there's only one electron, it's spin up, so M sub S is equal to +1/2. All right, so again, every time there's a 1 doesn't mean that M sub L equals 0. Let me show you the next example on oxygen. So let me just fill in this first. So we get 0, 0, 0, and +1/2. All right, oxygen. Oxygen's electron configuration ends with 2p4. So these are all the 2p's. The M sub L is -1, 0, and +1. If you want something to remember, the middle box is always M sub L equals 0. All right, so it's in the second energy level, the last electron. The L is equal to 1 because it's a p orbital. The last electron fills in the -1 box here, and it's a spin down, so it's -1/2. Remember, these quantum numbers only refer to the very last electron in oxygen. It refers to the 2p4 electron, not all the 2p electrons, only the 2p4, only that one, none of the others. All right, nickel. The question would be, what is that electron? What's the very last electron in nickel? So n equals 3, because it's the third energy level. The D's mean L is equal to 2. And to get the last 2, we really have to draw out the orbital diagram. So this is what the 3 Ds look like. There are 5 different boxes, and let's put in all 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. So the M sub L values go -2. Remember, it goes from -L to +L. So -2, -1, 0, +1, and +2. So the last electron's in the 0, so M sub L equals to 0. And then it's a spin down. So M sub L equals 0. Spin down, so it's -1/2. It's in the third energy level, and it's in the d orbital. All right, I could keep doing more examples. You don't have to watch all this, but I'm going to actually assign all the M sub L's to every single orbital that's in the atom. So 0, 0, -1, 0, +1, 0, -1, 0, +1, 0, -2, -1, 0, +1, +2, -0, +1. All right, if you'll notice, an S has an L equal to 0. An S has an L equal to 0. A P has an L equal to 1. That's why it goes between negative L and positive L, so negative 1 and positive 1. S is 0, L equal to 0. All right, L equal to 1, L equal to 0, L equal to 2. Right, again, notice it goes from negative 2 to positive 2. So S's have L equal to 0. They only have one possible orbital. P's have L equal to 1. They have 3 possible orbitals. D's have L equal to 2. They have 5 possible orbitals. And we might as well do this one for completeness. All right, a reminder, that's how to get the M sub L, and that's how to get the L. But the N is the energy level, so N equals 1, N equals 2, N equals 2, N equals 3, N equals 3, N equals 4, 3, 4. And then the spin up and spin down is the M sub L. All right, remember again, we're always dealing with the last electron in an atom. So for instance, in fluorine, is it this one or is it this one? Well, this one adds the last. So that means that you're going to have an M sub L equal to 0, and L equal to 1 because it's a p orbital, and N equal to 2 because it's in the second energy level. So these three numbers cumulatively mean 2p5. And then it's a spin down electron, so it has to be M sub S is negative 1/2. All right, if you have any questions, please don't hesitate to ask me after school, or even give a quick question at the beginning.